And this one's go through the process of finding the derivative of the square root of x from the definition. So let's take a look. It looks like this. I'm going to say here, this is my f of x equals the root of x. And now here, step 1. Step 2 means I need to find this limit. Limit as h goes to 0 of the following. F of x plus h minus f of x divided by h. In our context, notice that the f basically is the root function. So that means wherever I see x, first I replace it with this, x plus h. So it's going to be the limit as h approaches 0 of the root of x plus h. So here, wherever I see x, I replace it with x plus h. That's why I put root of x plus h. Then I'm going to subtract from it f of x, the original definition, which is just the root of x. And then I divide that by h. So this is the basic difference quotient. Then you take the limit of that as h goes to 0. And that gives you then the derivative of the root of x. So at the next step, I'm not going to put the limit there every time because it's not necessary. I'll put it in at the end. I need to work on this expression. Right now, this expression has a problem, which is that if you input h equals 0 directly, you will have this. So imagine that you set h equal to 0. There's a problem. The problem is you're going to have this. You're going to have x plus 0 minus the root of x over 0. And you end up with this. X, the root of x minus the root of x is 0. And the bottom you have 0. So that's no good. You can't have it in this form because you cannot divide by 0. That's telling you that you got to take an additional step, which is to transform this expression. So I'm going to take the step 3 basically here, and I'm going to do things differently. I'm going to take my root of x plus h minus the root of x over the h, and I'm going to multiply by the conjugate. The conjugate is this expression x plus h, but here instead you put a plus. So you're going to multiply by the conjugate. So let's say this is step number 5. Again, I'm just working on the expression to transform it into a more useful form. I'm not worrying about the limit just yet. So when I work on this, I'm multiplying by this. I'm multiplying by x plus h plus x over that same quantity, x plus h plus the root of x. And I can do that because remember, this expression right here, this is just a fancy form of the number 1. You're allowed to multiply by 1 as much as you want, or a form of the number 1. Here, this is the form that is convenient. So let's carry out that multiplication. So I'm going to use FOIL basically. FOIL says you take this and you multiply by that. That's going to give you x plus h in the root and then squared. So you're taking whatever this is, multiplying by that. That's like that quantity squared, the root of x plus h squared. Then FOIL says the root of this quantity times that. That's going to give you plus positive x times x plus h. Then FOIL says this times that. So the negative of the root of x times the root of x plus h. So it's going to give you minus, therefore, here, the root of x times x plus h. And then that's an h in that position here. I want to make sure you can see that. And at the end, you're going to have the negative x times that x right there. So it's going to give you minus the root of x squared. That's just the tops multiplied out. So let's simplify just the top for now. Never mind the bottom. This cancels that because the root and the square are opposites. That just gives you x plus h. This term and that term are identical. The only difference is they have different signs. So for that reason, like this crosses off with that. At the end, you have again, that 2 can cancel off the root. So you end up with just x. Like this, minus x. When you work this out, now the x's cross off, and you end up with just h. This is the top. Let's rewrite this now. It's step number 8. I'm going to say the following. The new top is h. On the bottom, you're going to do this. Go back to step 5. It's this h times that bottom, which is the root of x plus h plus the root of x. When you look through this, I hope you can observe that the h's can be cancelled. So when I work that out, I cancel off the h's. Remember, this h in the top is really h times positive 1. Therefore, here, it's as if you're basically erasing the h's, right? This h goes away, and this h goes away, and you're left with that expression. Continuing up here with step number 9. I hope you can still see that up there. I'm going to take the limit now. So here, I need to make things a little bit smaller, but hopefully still fit them, because as you can see, it takes a lot of space to write this out. So step number 9 is going to be this. Limit as h approaches 0 of this expression from step 8. And remember, up here there's a 1 left. So it becomes 1 over the root of x plus h plus the root of x. In this case, in step number 9, you can just plug in h equals 0 directly. You're not going to have any weird like division by 0 anymore. So what I'm going to do is leap over part of step 6 down to step 10 right here, okay? I hope you can follow the logic. Just replace back in step 9 h with 0 directly. It's going to give me 1 over the root of x plus 0 plus the root of x. I hope you're following that. At step 11, I simplify. This goes away, and I end up with 1 over the root of x plus the root of x. I'm being super detailed, which means at step 12, I end up with 1 over 2 times the root of x. And this quantity, 1 over 2 times the root of x, that is basically f prime of x. This gives you, by the definition, the derivative of the root of x, the way you see it. That is it for this one. Thank you so much for watching. Leave a like. I hope this has been truly helpful. I'll see you in another video.